Hello everyone, welcome to this lecture video tutorial in the mathematics of the modern world. Enjoy learning. Hello everyone, in this video I will discuss the solutions or answers to practice exercise and um, problem sets in the uploaded module for lesson 1, which talk about sets, and lesson 2, which talk about relations and functions. So without further delay, let's start our first problem. So as you can see here, for number 1, describe the following sets by both roster and rule method. So for number 1, uh, number 1 solution, letter A. So you are going to describe the set, the set of even integers greater than 0 but less than 10. So this is 2, 4, 6, 8 only. Since as you can see here, it is greater than 0 but less than 10. Okay, so this is for the roster method. For the rule method, we have, this is the set of all x's that x is an even number, is an even number greater than 0 but less than 10. Okay, so for letter B, for the roster method, the set C of distinct, as you can see here, letters in the word carpenter. So we have distinct C, A, R, P, E, N, T. Okay, E and R is repeated, or are repeated. So for the rule method, we have the set of all x's that x is a distinct letter in the word carpenter. Okay, so that's the solution for number 1. For number 2, let's have another color solution. First is you have to write the sets x, y, and z to roster method. So this is all our distinct letters. So force P, comma U, comma R, comma S, comma Y is pure, Z is rate. So I think in all sets x, y, and z, there are no repeated letters. Okay, so for question 2a, so y is a subset of x. So y is a subset of x, so mean all the elements of y are also elements of x. So we have b common, u, r, e. So the answer is yes. For letter b, z is a subset of x. Z is a subset of x. So we have r is also an element of x, e, a. So a here, as you can see, is not an element of x. So the answer is no. Letter c, x minus z is a subset of y. So first is we have to compute x minus z. So x minus z, x minus z here is, our x is this one, minus z, ap. So the answer is r is common, let's have another color. R is common, e is common, a, p is common. So we have here u and s. So is this set subset of y, u, but s is not an element of y. So therefore the answer is no. Okay, how about letter d? Let's put it here. Letter d, y and z are joint sets, meaning there is an intersection between y and z. So clearly we have a common, so the answer is yes. We have p here as a common element, so meaning they are joint sets. Okay, that's number 2. So for number 3, let's compute it somewhere here. Number 3, where's number 3? So again, convert all these sets to using Rooster method first. Okay, so u universal is distinct letter, again they are distinct, so d, I, c, t, I is repeated, o, n, a, r, and y. Okay, dictionary. So we have set a, diary, so there's no common element. B, nation, n is common. C, crayon, n, there's no common element. Okay, to find letter A, sorry. So we have A intersection B, which is the common of A and B. So the common is D, I is common, A is common also, R is not common element, Y. Okay, so I and A is the answer for letter letter A. So second is A union C, complement. A union C. So you can write the common, not common, but you have to write the elements, both the elements of A and C. So we have D I A R Y. So from here, from B we have N, A is common, T, I is common, is already here, O. Okay, then take the complement. So we have base it to the universal set. So diary, D I A, so D I, so C, T is common, O, N, A, R, Y. Okay, so we have only one element. Okay, dictionary, am I right? D I C, C is not T, we have a T O, N, A, R, and Y. Okay, so that's for letter B. For letter C, we have A complement intersection C, or A prime. So first is take the complement of A. So the complement of A is the set of elements in U that does not belong to set A. So we have D, I, A, we have A, C, T, O, N, no N, A, we have A common, R, we have Y also. So this is the complement of A. Intersection with C, which is crayon. So the answer is common. We have C, T, O common, N we have common. Okay, so that's the answer for letter C. For letter D, we have A minus B union C. So first, if you have to get the difference between A and B, so the common is, so let's try to eliminate. We have common A minus B, and we have A common here, T, I common here. Oh, okay, the answer for this one is DR, dry, DRY. And then union with C, your C is crayon. So the answer is we have union. So try to put first the dry, then put the other elements to this set. R is common, A is not an element of here, so Y is common, O is N also. Okay, so this is your answer for letter D. Okay, for number 4, I did not discuss this in our previous video. So what do we mean by the power set? Okay, the power set of a given set. So okay, this is the definition of the power set. definition, the power set of the set A, denoted by P of A, script P of A, is the set of all subsets of the given set A. Okay, so before we answer number 4, let's have an example here. Example number, this set. If you have a set A which is denoted by 1 and 2, the power set of A is, as you can see here, it is the set of all subsets. So meaning to say, you have to get all the subsets of A and then put it in this notation. Okay, so the subsets of A are, the subsets of A of the set A are the following. So we have this one, 1, which is a subset of A. 1, 2 is also a subset of A. Okay, 2 also is a subset of A, and we know that the empty set is a subset of any set. Okay, so therefore P of A is these sets here. First is you have to put the empty set, and then 1 set containing 1, and the set containing 2, and then the set A. Okay, so as a reminder or note, the cardinality of the power set of A is given by 2 to the n. Okay, so this notation is the cardinality. So meaning to say, where n, where our n is the cardinality of A. Okay, so meaning to say, or this notation, you remember this notation, n is equal to n of A. Okay, so this symbol here, absolute value and n of A, are the same. Okay, so notice in our example, the cardinality of A is 2. We have 2 elements, 1 and 2. So 2 to the 2, if you substitute here, 2 to the 2 is 4. So we have 4 elements of the set P of A. Empty, this set containing 1, this set containing 2, and this set also. So 1, 2, 3, 4. Okay, so let's have another example here. Example number 2. Let's say if you have a set B which contains 4 elements, A, B, 1 and 2. Okay, so notice that the cardinality, so somewhere in your brain or in your mind, okay, so you are thinking that the cardinality of this set is 4. So n of B is 4. So therefore the cardinality of the power set of B is 2 to the 4, which is 16. Okay, So meaning to say there are 16 elements of the power set of B. Okay, so these are the subsets of B. Okay, so first is, don't forget that you have the empty set. Okay, and then uh, take all those sets which contain only one element. Okay, so we have a this one, uh, so first is get the subsets of okay, get the set subset of A which contain only one element, and then the next one is take those subset of B that contains two elements. So what you will do here is like this. Okay, uh, this is the easiest way to know or to get the subset of the set B. uh, Take all, this is only these are the, what they call this one, the set containing one element, so this one, and then the set containing two elements are this one. Okay, so we have AB, A1, A2, and then also this one, B1, B2, sorry, A1, A2, B1, B2, B1, B2, and then we have 1, 2. Okay, so from here we have AB, A1, A2, and then B1, B2, and then 1, 2. So these are the subsets of the set B which contains two elements. Okay, and then next is get those subsets of B that contains three elements. So from here we have to use this one first, AB1, AB2. Remember that AB and BA are the same. Okay, in sets it doesn't matter if the elements are uh, rearranged, meaning to say that AB and BA are the same. Okay, 1A and A1 are the same. So AB1, AB1, AB2. So get a partner here. We have, let's try this color, this one, AB1, AB2, and then A12, A12. So A12 and then stop. Then we have B12. Okay, so these are the subsets of B that contains three elements. So from here we have A comma B comma 1, A comma B comma 2, A comma 1 comma 2, and finally B1. These are the subsets B that contains three elements. Okay, so there is on, and the last one is there are only one element, one subset that contains four elements. So therefore, uh, the power set of B is, as you can see in our previous analysis, we have 16 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15, and 16. So put all these sets here, B 1, sorry, 2, and so on and so forth. So everything here, okay, everything, put it here. Okay, so there are 16 all in all. So for that's how you are going to get the power set of A. So from here, the power set of N, this problem number 4. So our N is A, K, and O. So as you can see, so the cardinality of N is 3. So therefore the power set of N is 2 to the 3, which is 8. So meaning to say, you have to get the subsets of N. So these are the subsets of N. These are the subsets of the set N. Of course, you have the empty set first, and then get the subset of N which consists of only one element. So first is we have this one, A, K, and O. So these are only the subsets of N which consists of one element. So, and then to get the subsets of N which contains two elements, this one, use this method. So we have A, K, AO, and then KO. KO. Okay, these are the subsets of N which consists of two elements, and then finally there is only one subset of N that consists of three elements. So therefore the power set of N is this one. There are 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have empty, consists of one element. Sorry, AK and O, and then AK, AO, comma, don't forget to put a comma, and then KO, and then finally the set N. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 elements of the power set. Okay, for problem number 5, this one, shade the area represented by, where's that one? Okay, so meaning to say this is your sets, and then you are asked to shade the region, this one. So for letter A, you have to copy everything. One, make a circle, and set A, B, and C. So you have to get the intersection of A and C. So the answer is A intersection C is this one. Can I use this one? Let's try a blue color. Okay, so that's the shaded region for A intersection C. For letter B, we have A, B, C. So B intersection, B union C complement. So the union of A and B, B and C is this one. You shade this region. Okay, you shade this region here. Everything because this is union, and then take the complement. So the complement is outside. So this is the shaded region. So we shade. I'm sorry. Okay, so that's the shaded region for letter B. For letter C, let's try to answer this somewhere here. We have, let's make a figure. So we have A, B, and C. So we are asked to get the shaded region of this problem. B minus A intersection C. So first is you have to get the intersection of A and C. So the intersection of A and C is somewhere here, this region here. Okay, and then you have to get the difference. So the answer is this one. Can I? Okay. Okay, this is the B minus the quantity A intersection C. So that's for the first, that's the problem set, practice exercise 1 up to 5. Okay, and let's continue for this problem here. This is the verbal problem. So number 6, solution for number 6. We have, first is, okay, so it says here, our set is B, F, and V. So this is set P, basketball, football, and volleyball. So first is start at the bottom. Start at the bottom and then move upward. Okay. So one athlete played all three major ball games. So this is one here. Two athletes played football and volleyball. So BF is 2, BF is 2. So we have 1. So this set here, there are this player or athlete here contains 2, as you can see here. Okay. So for this one, 3 athletes played basketball and volleyball. Basketball and volleyball we have 3, so we have put 2 here. 2 plus 1 is 3. Okay. So for this one, 2 athletes played basketball and football. Basketball and football we have 2 athletes, so we have 1. 1 plus 1 is 2. Okay. 12 athletes played volleyball. Volleyball 12, so 2, 3, 4. 12 minus 4 is 8. And then 18 football, 18. 1, 2, 3, so we have 15 here. And then 16 athletes played basketball. 16. So 4. 2, 3, 4. 16 minus 4 is 12. Okay. And as you can see here, there's no other given. Okay. So meaning to say this is it. So to answer letter A, what is the total number of athletes playing the 3 major ball games? So you have to add all these numbers here. So we have 12 plus 15 is 27, plus 8, 35, plus 2, 37, plus 1, 38, plus 1, 39, 39, plus 2, 40, 41, plus 1 is 42. So there are 42 athletes. Letter B, how many athletes played exactly 2 major games? So this is the answer, 2 major games. This one. Okay. So we have 2 plus 1 plus 1. Okay. This is 2, 3, 4 athletes. For letter C, how many athletes played basketball but not volleyball? Played basketball but not volleyball. Played basketball. Here's that one. So I guess this portion here, played basketball but not volleyball. So we have B minus V. This one, this portion here. Okay. Okay. So the answer is 13. 12 plus 1, we have 13 athletes. Okay, played basketball but not volleyball. Okay, so that's practice exercise number 1 up to 6. Okay, so for the problem set here, problem set 1A. So problem set 1A. So number 1. So again, you are going to write this set to roster and rule method at the same time. So for the roster method, the prime numbers less than or equal to 29 is the prime number will start at number 2. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 25, no, less than or equal, so 29. Okay, 25 is not a prime number. 26 is not a prime. So how to write this as a rule method? So this is the set of all x's that x is a prime number. So these plural word numbers with s become singular. Prime number less than or equal to 29. Okay, so letter B. For letter B, we have W. Roster method, the days in a week. So we will start at Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and then we will have Saturday. So for the rule method, which is the set of all x's that x is a day in a week, is a day in a week. Okay, so for example, we have Sunday is a day in a week, so our x is somewhere, it's one of the elements of W here above. Okay, so that's problem 1. For problem number 2, okay, so since the given are already in the roster method, so this is for me easy to verify now. Okay, so let's try to answer this. A is a proper subset of B. A is a proper subset of B. So the answer is false. Okay, proper subset is something that the definition is all the elements of A is also in B but cannot be equal to P. Okay, so for letter B, A is a subset of B. Again, 1 is not an element of B This is false. For letter C, B proper subset. So this is clearly a proper subset. uh, A and B is not equal. So 2, 4, 6, and 8. This is true. B is a, so this is true again. Okay. So what is the difference between proper subset and subset? Okay, so as you can see here, this is true. B is a proper subset of A, but also B is also a subset of A. So what's the difference? So for example, if your A is for example, your A is 135 and your B is 531. Okay, so here this implies that B is a subset of A, but B is not a proper subset of A because A is equal to B. Okay, so that's the difference between proper subset and subset. Okay, so to answer letter E, so B and C are joint sets. So if they're a common, no common, so this is false. C is a subset of C. This is true because all elements of C is also an element of itself. Okay, so letter number 3. So for number 3, first is you have to get the roster method of sets U, A, B, and C. So counting now the set of all x is that x is a counting number less than or equal to 15. We know that the counting number starts from 1, so we have 1, 2, 3, and so on up to less than or equal 15. So for letter A, the set of all x, even counting number less than or equal to 15. So even start with 2, 6 up to 14. Set of all x, add counting, so 1, 3, 5, and so on up to 15. Prime number less than or equal to 2, 3, 5, 7, 11, 13. Okay, so to answer letter A, the intersection of A and B is this is 6, sorry, so this is 6, 2, 4, 6. So since set A is a even number and set B is the odd counting number, the intersection is empty. For letter B, the union of A and C. Union of A and C. So as you can see here, the union of A and C is 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 is in here, 9, 10, 11, 12, 13, and 14. Okay, only. So the complement of this set is the set of all elements in the universal set that does not belong to this set. So the answer is the set containing only one element, which is 15. So first is get the complement for letter C. Complement of A. The complement of A is B. Okay. So the complement of even is add. So this is B. The intersection of B is, of course, itself. Okay. So letter D. A minus B. A minus B. So there's no common between the two sets A and B. So if you take the difference, the answer is itself. So we have A union C. So A union C is here. We have in letter B. So 1 up to 14. 3 and so on up to 14. Okay. And then the first, so letter E, get the intersection of first is get the intersection of B and C. So we have a grouping symbol here. So B intersection C. 3, 5. I guess this is 3, 5, 7, 11, and 13. Okay, then get the union. So we have 2, 3, 5 union with A. No, this is not correct. 2, 3 union with A. So 2, 3, 4, 5, 6, 7, 8, 9 is not an element here. 10 we have in A. 11, 12 element of the set A. 13 we have, then 14 union. So 15 is not an element. Okay. So that's the answer for letter E. For number 4, we have 4 elements. So to answer the power set of this set is the same as I will not answer this question. This is the same as in the example before. This example, set containing 4 elements. Where's that one? I guess this one. Okay, this example. Where's, okay, this one, this set. Okay, so all you have to do is to compare this problem to the second example. So for number 5, let's try to solve number 5. Shade the region. For 5A, 5A, this is 5, letter A. Copy the diagram first. Okay, Okay, this is our A, B, and C. What is A union C? Okay, so let's try another color. Let's say, and we have this green here. A intersection C. A intersection C is this one. Okay, that's A intersection C. For letter B, so again, copy the diagram. We have A, B, and C. So our problem is to get the complement of the intersection of B and C. The intersection of B and C is this one. Okay, so get the complement, meaning outside. Okay, so outside, so this. Okay, so that's letter B. For letter C, let's make a diagram again. And then create a circle. We have A, B, and C. So the problem is to get this one, B minus A union C. Okay, let's go back. Okay, so we have to shade this the region represented by this problem. So first is you have to get the the union of A and C. So the union of A and C is to shade all this region here and then get the difference. So if you get the difference, so the remaining shade region is this one. Okay. This one here. The shaded region of this problem. So for letter D, let's have letter D. Copy again the problem. We have A, B, and C. So our problem is, where's that one? A union C minus A union C. A union C minus B intersection C complement. B intersection C complement. So this term here is the answer for letter B. So this is the complement of C is this region here, and the union of A and C. What's the union of A and C? The union of A and C is this one, this whole portion here. So if you take the difference, so what is the answer? This one, you take the union, so the remaining is this portion here. Okay, so I think this portion is the answer. Okay, to erase somewhere. So get difference minus, move outside. Okay, so that's the answer for letter D. Okay, so for this problem, last problem, let's try this color. Number 6 solution. In a class of 40 students, so there is this number here. In a class of 40 students, 18 of them are taking mathematics. So 18 of them are taking mathematics. English is E, 15, and then chemistry is 50. Sorry, this is 20. This is 20 and this is 15. Okay, and then 11 are taking English and chemistry. So English and chemistry, the intersection is 11. Mathematics and English is 6, and then mathematics and chemistry we have 4, and taking 3 subjects, the intersection of mathematics, English and chemistry is 2. Okay, so these are your question. So first is make a diagram. This diagram here. So make a 3 sets for M, mathematics, English and chemistry. So start at the bottom and then move up. So this one here we have 2, and then mathematics and chemistry is 4, so we have 2 here. 2 plus 2 is 4, and then mathematics and English is 6, so we have, so 4 plus 2 is 6. English and chemistry is 11, so we have 9 here. 9 plus 2 we have 11. So chemistry is 15, 9, 10, 11, 12, 13, so we have 2. English is 20, 9, 13, 14, 15, so we have 5 here. and then 18, 4, 8, so we have 10 here. Okay, so in the problem also it is mentioned that there are 40 students in the class, so you have to add all of this and then subtract to 40. So 10, 15, 17 plus 9, 26, 30, 34. So 34, 40 minus 34, we have 6 outside. Okay, so for the first question, how many students are taking only one subject? Only one subject. So we have here, we have 10 plus 5 plus 2. We have 17 students. Okay, for letter B, how many students are taking two subjects? We have 4 plus 2 plus 9. We have 15 students. For number 3, how many students are not taking any of the 3 subjects? We have this one, 6. Okay, 6 students. How many students are taking mathematics but not English? So M minus E, but not English. So this one, 10 and 2, M minus E. So we have 10 plus 2, which is 12 students. How many students are taking both English and chemistry? Both English and chemistry but not mathematics. So these numbers are 2, 9, and 5. Okay, 2 plus 9 plus 5. The intersection, this means that this problem here, letter E, is just like the intersection, no, the union of the English subject and the chemistry subject minus mathematics. Okay, so these numbers here, 5, 9, and 2. So this is 16 students. Okay, so that's all for this practice exercise. Okay, for lesson 1. So for lesson 2, we have this. That's our next discussion. Okay, okay, for this practice exercise, lesson number 2, in the topic relations and functions. So for number 1, as you can see here, you are going to determine if this relation 1a, b, and c defined as a function of x. Okay, so for number 1, one solution, letter A. So as you can see here, if you look at your this problem is falls on the topic functions or relation described by a diagram. So if we zoom out, as you can see in the graph, in the diagram, that each element in the domain maps to one and only one element. So in every object in the domain, there's only one arrow. So this means that this is a function. Okay, so 1a, this is a function. Letter B, in if you recall our discussion in relations and functions, describe using the ordered pairs. It says that if there's no two ordered pairs have the same first component, then that given is a function. So 4, negative 5, 0, 8. So meaning to say this is a function. So for letter C, it violates the definition of a function. Why? Because there's an ordered pair, negative 1 and 6 and negative 1, 4, uh, in which the ordered pair, in which the first component is the same. So meaning this is not a function. Not a function. Okay? So that's the answer for 1, letter A, B, and C. So for number 2, use the vertical line test to determine whether the relation defined as a function of x. So based on the definition of the vertical line test, if you draw a vertical line in the graph, if it intersects the graph more than once, then the function defined by the graph is not a no, the relation defined by the graph is not a function. So number 2 is not a function. So if you draw a vertical line, it touches the line more than once, so meaning to say this is not a function. Okay, so for number 3, given the function defined by this set, find the value if you substitute. Okay, so for letter A, so our given is g of x, which is equal to 4x minus 3. So for letter A, we have our A here, so we need to say we have to replace our x by A. So this answer is 4a minus 3. For letter B, we have g of x plus h. So substitute, replace x by x plus h. So 4 times x plus h minus 3. Simplify, we have 4x plus 4h minus 3. Okay, so that's problem number 3. For number 4, write the domain and the range in the interval notation. Number 4, this is our, let's say this is letter A, B, and C. Okay, for letter A, f of x is equal to negative 6. So notice that there is no variable in the denominator. So meaning to say this is always defined for all values of x. So our domain, d sub f, is, this is our notation, the set of real numbers, while the range is, as you can see, the range is the set negative 6, containing the element negative 6. Okay, that's the what they call this one, that's the range. If you look at the graph, y is equal to negative 6, y is equal to negative 6. This is the graph. Okay, so as you can see, for all x from negative infinity, from here, from negative infinity up to positive infinity, we have a value. So this is always mapped to number 6. So if you try to explain this in the what they call this one, in the diagram form. If you have a this one is the diagram. We will try to describe the function f of x, which is equal to -6 in the diagram form. So this is our domain and this is our codomain. So notice that the domain is a set of real numbers. This one, -1, negative, and so on, -5, and so on and so forth. 1, 2, 3, and so on and so forth. Here we have -6. Our codomain is the set of real numbers. Okay. Here one. Okay. So all these numbers are mapped to -6. Okay. So meaning to say, -6 is the only element that is mapped for all elements in the domain. So meaning to say that the range is this set here, -6 contain -6, but the codomain is a set of all real numbers. So as I've said in the previous discussion, that the range are a subset of the codomain. For letter B, we have the domain is domain of the function. So this is a linear function which do not have a variable in the denominator, meaning to say this is always defined for all values of x. So this is the set of real numbers, while the range, if you study your module, the range of the linear function is the set of real numbers. But if you will try to solve it using the method that I explained to you in the video before, to find the range is to solve for x in terms of y and then determine the biggest values of x for which y is well defined. So this is y is equal to 6 plus x. Am I right? Okay, so let's wait for the program to respond. 6 plus x. So interchange the rule of x. So we have x is equal to y minus 6. So as you can see here, there's no y in the denominator. Okay, this is always defined for all values of x. So therefore, the range is the set of real numbers. Okay. So for letter C, we have h of x. Letter C. H of x is equal to 2x plus 1 over 2x plus 1 over x minus 9. Let me check it. 2x plus 1 over x minus 9. Okay, so the domain for this function is the set of real numbers except 9. Why? Notice that for all values of x, the 9, if you substitute 9 here, the denominator becomes 0, and then a number divided by 0 is undefined. So that's how you're going to find the domain. So to find the range, r sub h is to solve for x in terms of y. So we have to compute 2x plus 1 over x minus 9. So cross multiply, and then this is y, x minus 9 to x plus 1. So distribute, and then put all the terms which has a variable x. So this term here, so xy minus 2x is equal to 9y plus 1. So factor out x, y minus 2, we have 9y plus 1. So then divide both sides by y minus 2. So what we have here is x is equal to 9y plus 1 over y minus 2. So this is always defined except for y which is equal to 2. So why? Because if you substitute 2 here, the denominator becomes 0. So this is the set of real numbers except positive 2. So that's how you are going to find or determine the range of the function. Okay, so that's problem number 4. So for problem number 5, by making graph this one by making a table of ordered pairs. So the graph is very simple. If you look at here, so we have 6 plus x, 6 plus x. So this is the graph. Okay, so just take a value, let's say number 6 here, number 5, sorry, number 5. So just create a table. Maybe since this is a line, you can what do you call this one, you can pick only 2 values, because we know that in our algebra that 2 points determine a line. So just try this value 0 0. So substitute. So y is equal to 6 plus x. So substitute 0 here, we have 6. If you substitute 0, we have negative 6. Okay, so just try this value 0 and 0 for x and 0 for y, and then graph it using this one. I guess I will use a sorry let's move to 90 degrees, and then let's try this color. And then to 0 degrees. Okay. So let's try 0 6. So 1, let's say 1 2 3 4 5 6. So 1 2 3 4 6. So 0 6 is this one. This ordered pair corresponds to 0 6, and this one is negative 6 0. So this point, so okay. For the other one, just use scaling, proper scaling. So we have 1 2 3 4 5 negative 6. So negative 1 negative 6, so negative 6 0. Okay, and then use your ruler, if you have a ruler, say this one. Let's wait for the program to respond. Okay, let's try this program. Which is the same as in the Dismos graphing calculator. Okay, so that's how you are going to graph the problem in number 5. So for number 6, given the function defined by this one, evaluate the function h1, 2, 3, 6, 10. So for number 6, so again the problem is x minus 1, square root of x minus 1. Number 6, square root of x minus 1, and then you are going to find h of 1, h of 2, h of 3, h of 6, and h of 10. So all you have to do is to substitute 1 minus 1, this is 0. 2 minus 1 is square root of 1, which is 1. 3 minus 2 is square root of 2. 6 minus 1, which is square root of 5. And then 9 minus 1, which is 10 minus 1, which is square root of 9, which is 3. Okay, do not use decimal form. So that's number 6. For number 7, given the function, again this is the same as number 5. So remember that in this problem, the number 7, the domain of the function is, as I've said before, the square root function is defined for all positive numbers, non-negative numbers. So meaning to say that 1 minus x must be greater than or equal to 0. Okay, so that means if you solve this inequality, we have x is less than or equal to 1. Okay, so the domain is from negative infinity to 1, including 1. Okay, so if you try to graph this equation in our Desmos calculator, we have square root of 1 minus x. So as you can see here, sorry, we have x 1 minus x. Okay, so the domain, clearly the domain starts from negative infinity up to 1. So the range is clearly in the graph, starts from 0 up to positive infinity. So the range is based on the graph, the range is from 0 to positive infinity. Okay, but if you will try to solve it analytically, then notice that this is your function, and then solve for x in terms of y. So we have to square that one both sides. So we have y squared is equal to x minus 1. So x is equal to y squared minus 1. Okay, remember that our x is from negative infinity to 1. So the values of when you try negative 1, negative 1. If you try negative 1, negative 1 square is something like 0. Okay, so as you can see here in the graph, the domain is upward from 0 to positive infinity. Okay, so just analyze this one. So for number 8, let's try to move this downward. Okay, for this problem number 8, you are going to find the inverse of the domain, the inverse domain and range of the function. So it is assumed that this is a function, since in our previous discussion, letter A, the function f, the mapping is not stated, so it is assumed that our domain here is the mapping from G, A to B. So it is assumed that our domain here is a subset of, our domain of G is a subset of A, which is the set of real numbers, and our codomain is the set of real numbers. Okay, so this is obvious. The domain of the function, this is a linear function, so therefore the domain is a set of real numbers, and as you can see here, there's no variable in the denominator also. So to find the range, this is linear, so the range is expected to be a set of real numbers, but you have to use the steps that I discussed before. All you have to do is to solve for x in terms of y, and then determine the values, the biggest values of x for which y is well defined. So from here we have g of x is 4x minus 8, so y is equal to 4x minus 8, and then solve for x. So we have 4x is equal to y minus 8. Divide both sides by 4, so we have x is equal to y minus 8 over 4. So our intuition that the set of the range is a set of real numbers is true, because as you can see here, there's no variable in the denominator. Okay, so that's it. That's how you are going to find the range. To get the inverse, notice that the range and the codomain is equal, so meaning to say that this function is onto. And we know also in the previous discussion that the linear function is a one-to-one function. Okay, so therefore the inverse of this function g exists. Okay, so inverse since the range is equal to the codomain, the function g is onto. Okay, so to show that it is one-to-one, to show that it is a one-to-one function, we have to let two numbers in the domain. Okay, and then we are going to show by computing g of a and g of b. We have to show that a is equal to b. Okay, so based on our discussion here, 4x minus 8, the given is 4x minus 8, so this is 4a minus 8, and this is 4b minus 8, and then simplifying, so this is 0, so what remains here is 4a minus is equal to 4b. So divide both sides by 4. So as you can see, we have a is equal to b. Therefore, the function g is 1-to-1. Okay, so to find the inverse, okay, you have to interchange the rule of x and y. So our given is y is equal to 4x minus 8, so interchange the rule of x and y. So from here is interchange the rule of x and y, and then solve for y in terms of x. Okay, so this is 4y x plus 8. So transpose negative 8 to the left side and then use the symmetric property. So then divide both sides by 4. We have y is equal to x over 4 plus 2. Okay, so here is solve for y in terms of x. So this is now our inverse, x over 4 plus 2, or this is 1/4 x plus 2. Okay, so as you can see, 4x minus 8. So let's graph 4x minus 8, 4x minus 8. And the graph of the inverse, 1 over 4 times x plus 2. Am I right? Plus 2. Okay, so this is the graph. The purple one is the original function, which is the function g, and this is the inverse, the black one. That's the graph of the inverse. Okay, so that's how you are going to get the inverse domain and range of the function. For number 2, let's copy this one, paste. Where are you? What's this? Sorry. Can I move that one by using the button? Okay, for letter B, for 8B, to get the domain, clearly the domain is -6, -9, -2, and positive 3. The range is, sorry, the range is 2, 0, negative 1, and 4, the second coordinate. To find the inverse of the function, is this a function? So we have, yes, no two ordered pairs have the same first component. Okay, so inverse is you have to interchange the, what do you call this one, the first coordinate and the second coordinate. 2 with negative 6, 0, negative 9, negative 1, negative 2, and then 4, 3. Okay, that's 8, letter B. For letter C, so let's wait for the program to respond. So for letter C, letter C, 4 over x plus 2. So 8, letter C, 4 over x plus 2. This is g of x. This is our given. No, this is f. Sorry, we have f. Okay, so notice that the mapping is not defined. So our mapping here, so it is assumed that our this is a function, so meaning it is assumed that the domain of the function is a subset of R. Okay, and the codomain is of course the set of real numbers. So from here we have to get the domain d sub f. So domain is y is equal to 4 over x plus 2 is the set of real numbers except negative 2. Okay, so when x is negative 2, the denominator becomes 0, so we have undefined. To find the range, all you have to do is to solve for x in terms of y, and then determine the biggest values of y for which x is well defined. So cross multiply, so we have y times x plus 2 is equal to 4, xy plus 2y is equal to 4, and then transpose 2y to the other side, then divide both sides by y. Okay, divide both sides by y. So we have x is equal to 4 minus 2y over y. So this is undefined when y is equal to 0. So the range is the set of all real numbers except 0. So as you can see here, the codomain is not equal to the range, so therefore this is not onto. So since this is not onto, the inverse of this function is do not exist. But there are times that they force it to compute the inverse by assuming that the codomain and the range are equal. So meaning to say, if you force it to get the inverse of this equation, all you have to do is to interchange the rule of x and y. Okay, so we have interchange, so x is equal to 4 over y plus 2. Then solve for y in terms of x. Cross multiply. And then xy plus 2x is equal to 4. And then solve for y in terms of x. Divide both sides by x. So this is our y. 4 minus 2x over x. So this is our inverse. F inverse of x. If you force it to get the inverse, but notice that it is not mentioned in the problem that the codomain is defined. So as I've said in our discussion, that if there's no mention about the domain and the codomain, then it is understood that the set that you are going to use is the set of real numbers. Okay, so that's how you are going to solve the, how do you call this one, the exercises. So for our problem set, this one, problem set 1b. So this is the solution. Letter A, write the relation as a set of ordered pairs. For problem number 1 up to 3 as a set of ordered pairs. Okay, so meaning to say, for this problem set 1b, this is the solution for this one, set of ordered pairs. So you will write it this way: 2.5, 4, 5, 6, and 7.5, 8, and 10, and then 10 and 12.5. Okay. For number 2, we have negative 2, 8, 2, 1, and 2, 2, and then 0, 8. For number 3, this is 1, 2, 3, 4, so 1, 1, 1, 1, 2, 1, 1, 1, 2, 1, 3, 1, and 4, negative 2. Okay, so that's how you are going to answer exercise number 1 up to 3. And this is letter A. Okay, this is letter A. I'm sorry. For letter B, determine the domain. So this is obvious. The domain is I will answer for 1A. For B, this one, 1. No, sorry. This is 2. This is 3. I will answer 1B only. So this is very easy. So for the domain is this one. Okay, these numbers here. We have 2, 4, 6, 8, and 10. This is the domain. Okay. So do the same for number 2, and the range is this one. 2.5, 5, do not repeat, 7.5, 10, and 12.5. This is the range. Okay. For number 4 and 5, to determine the domain and the range, for number 4, The domain is this numbers here. From there's no hole, so from 0 to 4, and the range is there's no notation if this is the function f or whatever. The range is from this point here up to there, so from negative 2 to 2. Okay, for number 5, the range is the domain is from this point. There is an arrow here, as you can see, so meaning to say from negative infinity to this point, so from negative infinity to 2. But as you can see, there's a hole here, so we will not include the point or the number 2. For the range, we have starting from this point. What's this point? Is this one? 1. Okay, that's 1. So including 1 to positive infinity. So these objects here, okay, all those points including 1. Okay, that's the range. For number 6, determine if the relations define y as a function of x. Number 6, so this one, this is a function. Clearly this is a function because as you can see in the domain, there's only one arrow. For letter B, no two ordered pairs have the same first component. Okay, this is a function.
50 points money now.
Function. This one, 0, 1/2, 1.1, and 4. No 2. So this is a function also. Function. Okay. So for number 7, use the vertical line test to determine whether the relation defines as a function of x. So we will use vertical line test. Where are you? This one. If you will draw a vertical line, as you can see here, it touches the graph only once. Okay, so meaning this is a function. Number 8, the same as in our previous problem. So for here we have g of a, which is 3a minus 5. For letter B, we have g of x plus h. Replace x here in our Venn by x plus h. So we have 3x plus h minus 5. So this is 3x plus 3h minus 5. Okay, number 9. Again, this is the same as in the previous problem. So for 9, the first one is A, B, C. 9a, domain and range in the interval notation. Okay, the domain of the function is the set of real numbers, and the range is only the set containing 1. This is the same as our previous example. 9 letter A, 9 letter B. 9 letter B. The domain of the function g is linear that's linear, so the domain and range are set of real numbers. For 9 letter C, this is rational. So the domain is, all you have to do is to find a value of x for which the uh, function is undefined, so the value is -9, so exclude -9. For the range, compute by what do you call this, solving x in terms of y. So what we'll do here is to write it in this form: x plus 9, so cross multiply, so y times x plus 9 to x minus 1, so xy plus 9y, and then solve for x in terms of y. So we have -9y minus 1, factor out x, y minus 2, we have -9y minus 1. So divide both sides by y minus 2. X is this one, -9y minus 1 over y minus 2. So the value of y for which x is well defined is +2. So the range is the set of real numbers except 2. Okay, so that's how you are going to use. Number 10, this is easy, just like before. Number 10, use this method, this one, pick two values only, 0, 0, okay, and then graph it. The graph is something like this. The graph looks like 6 minus 3x. 6 minus 3x. So this is the graph. Okay, so you can pause, and then while solving this function by making a table of ordered pairs. For number 10, this is very easy, just substitute. For 11, write the domain and range, and then make a graph. So the graph is something like this: square root of 2 minus x, square root of 2 minus x. So this is the graph again. The domain is from -infinity up to 2, while the range is from 0 to +infinity. So based on the graph, the domain is of the function f is from -infinity to 2, while the range is from 0 to +infinity. Okay, based on the graph. Again, just like before, just make a table of values. So the values that you are going to pick is from this set. For number 12, again, this is very easy. Just use the previous discussion. The domain of this is easy again, so let's compute letter C. Okay, 11C. 11 letter C. Y is equal to 2x minus 7 over 4 plus x. The domain, so it is not mentioned here the domain and the codomain, so we expect to be of this form, this one. where our domain is the subset of A, which is the set of real numbers, and the codomain is the set of real numbers. Okay, so the domain of the function is a set of real numbers except -4, as you can see here in the denominator. Okay, the values of x for which this function is not well defined is when x is equal to -4. We have a 0 denominator. So for the range is again compute solve for y in terms of x. So we have y 2x minus 7 over 4x, no, 4 plus x. Sorry. Let's wait again. 4 plus x. So compute, we have 4 plus x cross multiply. So distribute, we have 4y plus xy, 2x minus 7. Solve for x in terms of y, we have -4y minus 7. And then factor out the variable x. Okay, xy minus 2, 4y minus 7. So x is equal to -4y minus 7 over y minus 2. So when y is equal to 2, the denominator is 0. So we have undefined. So let's read. Set of real numbers except positive 2. Okay, so this is the graph. 2x minus 7, 2x minus 7 over 4 plus x divided by 4 plus x. So as you can see, this is the graph of we have an asymptote here when x is equal to 4, right? -4, sorry, -4. When x is equal to -4, clearly we have an asymptote. Okay, that one, the purple one. So this is how you are going to find the domain and the range. Again, the range and the codomain is not equal, therefore the inverse does not exist if you define it this way. But since there are times there are teachers that they assume that the range of and the codomain are equal, meaning the function is onto and also one-to-one, therefore the what do you call this one, the get the inverse of this function here directly by assuming that the function is one-to-one and onto. Okay, so from here you can interchange the rule of x and y here. This is your inverse, sorry, minus 7 over x minus 2. So this is the inverse. By computing the range of the function, you can automatically interchange. Okay, no, interchange the rule of x and y. Okay, so this is your inverse. Again, be cautious that if this is defined, then be careful with your solution. But if not, uh, in the multiple choice exam, you can choose maybe none of this or none of the above. Okay, so that's all for this video. So you can use this as a learning guide, or is if you want to study, you can use this for your next exam. Okay, tomorrow, I guess. So but before I will say goodbye, don't forget to subscribe and to click that bell button down below. Thank you so much for watching.